All right, this is lesson 8.1, translations. In Khan Academy, we're now working in unit 15 called performing transformations. And after this lesson, you should be able to do skills 1 through 4. Our objective is that after this lesson, you'll be able to translate points and shapes and determine the translation given an image and its pre-image. Our first fill in the blank there is a transformation is a general term for 4 specific ways to manipulate the shape of a point, line, or shape. So, transformations can be broken down. We're going to learn 4 different transformations. Today, in 8.1, we're going to talk about translations. In 8.2, we'll talk about reflections. In 8.3, we'll talk about rotations. And I want to point out now, though, that all 3 of these are what we call rigid transformations. What that means is they preserve congruence. If 2 shapes are congruent, that means they have the same size and shape. They're exactly the same size and shape. When we get to the end of our chapter in 8.4, we'll talk about dilations. That's the only one that we'll learn about that's called a non-rigid transformation. Dilations, they do preserve similarity. Remember, if 2 shapes are similar, that means they're the same size, but not necessarily the same shape. So to give you a quick example, thanks to modern technology, the Notes app that I'm using allows me to dilate images. I just drew a triangle, and I could copy it and paste it, and these 2 triangles are the exact same size and shape. They're congruent. But here, let me delete this second one. If I take this first image, it's called a pre-image, we'll get to that in a moment. But if I take this triangle and I stretch it out, I'm making it bigger, but it's keeping the same shape. Or I could even shrink it really small. It's the same shape as the original, it's just not the same size, and that's a dilation. But we'll get to that more in 8.4. Today is all about translations. So a translation is the process of moving one point or image from one spot to another by sliding the image. So, got a little bit more vocabulary for you. This note here, if you want to use highlighters, that's great. It's a good way to color code your notes. I'm just going to use different color pens. I'm going to use blue for the pre-image. This is our before, so what we're starting with. So let's say we have this shape here, and we want to slide it or translate it to get the image. Obviously, there's lots of points on the pre-image and the image. I'm just going to pick 3. Let's call this point A, this point B, and we'll call this point C. What I'd like you to do, since everybody knows how to plot points already, or you should by this point in your math career, can you tell me the coordinates of A, B, and C? So we have a pre-image. I just picked 3 of the points on the pre-image, A, B, and C. Go ahead and pause the video and tell me what are the X and Y coordinates of A, B, and C. Okay, so hopefully this point A here, you recognized its coordinates are 2, -2. The coordinates of B should be 4, -4. And the coordinates of C should be 7, 0. What I want you to do now is look at the after image. Look at the resulting shape here and mark where is the matching point. Where does A get sent to? Hopefully you're looking at this point right here. When we slide the pre-image to the image, this point A is going to get sent right here. We call that point A prime. This is red prime. It's really A just with a little apostrophe next to it. But you should know that it's pronounced A prime. So A apostrophe is red A prime. And it just means where the point A is sent to. Similarly, we have B prime here and C prime here. Oh, forgot my primes. There we go. A prime, B prime, and C prime. The coordinates of the points on the image should be -2, 5, 0, 3, and 3, 7. Pause the video and take a moment. See if you can notice a pattern to get from A to A prime, B to B prime, and C to C prime. This is the same translation, so there should be the same thing happening to each point A, B, and C to get A prime, B prime, and C prime. If you don't notice it yet, that's okay. By the end of this lesson, you should be able to. So moving on, you can move an image up if you add to the Y value. You can move it down if you subtract from the Y value. That should make sense. The Y axis is vertical, up and down, right? So let's get to our example. Our directions are going to be, let's just write it in black. Translate the point P down 2 units. All right, so we'll call this point P. You know what? I'll use blue for the pre-image. If we're going to slide it down 2 units, we better end up here, right? That's down 2 units. That would be P prime. But let's just make sure we can do it algebraically as well. So the coordinates of P is plotted at the point -2, 3, right? Well, if we use our algebraic rule here, then P prime should be at the point, well, we would need to subtract 2 to the Y coordinate. So it should be -2, whatever this 3 is. But then we have to subtract 2 to move it down 2, right? So isn't that the point -2, 3 minus 2 is 1? Let's double check. Is that the coordinates of this point? P prime, -2, 1. Yep, it is. And sure enough, we moved P down 2 units to get to P prime. We can also translate horizontally. We can move left or right. So to move right, we add to the X value. To move left, we subtract from the X value. All right, so again, we have point P here. It's the same point. P is at -2, 3. But this time, I want you to translate P to the right. And let's go 3 units. So same thing. We could visualize on the graph where P prime should be. I'm not going to write it yet. I'm going to use my algebraic rule. If I'm moving to the right, that means that I need to add 3 to the X value, right? So I'm going to take this original X value from the pre-image. I'm going to add 3 to it. The directions didn't say to move up or down, so I'm not going to do anything to this Y coordinate. I'm just going to leave it a 3. All right, but that, I can do -2 plus 3. That would be 1. So P prime should be here. Let's plot that. 1, 3 is here. That's our P prime. And we can check our work because we do have our graph. Yep, we moved it right 3 units. There's 3 ways to write a transformation. You can write it algebraically, using shorthand, or in vector notation. So if I gave you Like for example, if we're moving 4 units right and 3 units down, you could say P, and then parentheses XY. It would go to P prime, and we would add 4 to the X coordinate to move 4 right, and we would subtract 3 to the Y coordinate to go 3 down. You could use the shorthand notation. You could say, hey, this is a translation where we're moving 4 units right. To show 3 down, we would put -3 instead of just 3. And then same thing with vector notation. If you want to use these, they look like pointy parentheses almost, but same thing. 4 units right, 4 is positive because we're adding 4. And then 3 down means we're subtracting 3 to the Y coordinate. There we go. One thing I want to point out though, I guess I'll write it in purple. I often do this a little bit more shorthand. It's more proper to show P and P prime next to the coordinates, but sometimes I just jot down X, Y as an ordered pair and I show where that goes to. So it's being mapped to X plus 4 comma Y minus 3. And it's the same rule, I'm just not writing P and P prime. That's kind of implied. But you might see different notations on Khan Academy or in a different textbook. You should know what all 3 notations mean. All right, let's do a couple examples and then we'll be done. We have a figure CAT. It has 3 points, so that's going to be a triangle. Pause the video. I want you to graph these 3 points and connect the dots on your own. Make a triangle on the graph. All right, hopefully you plotted C at 1, -2, so that should be C. A should be at -2, 1, that's right here. A and T is at -3, -3. There's T. And I asked you to connect the dots, so your paper should look like this. There's CAT. That is our pre-image. And then again, we could write the ordered pairs here next to the letters. And since we're translating 1 left and 2 up, all of these points, we're going to subtract 1 from the X coordinate and add 2 to the Y coordinate. So our image, if we use this algebraic rule, C prime should be, well, our original X coordinate here is 1, and we're moving it 1 to the left, so we're going to subtract 1. That should go to 0. And then our original Y coordinate is -2. We want to move 2 units up. So we're going to add 2. -2 plus 2 is also 0. Do the same for A to get A prime and T to get T prime. And then come back and check your work. If we subtract 1 to the X coordinate, add 2 to the Y coordinate, we should find that A prime is at -3, 3, and T prime is at -4, -1. Awesome. Finally, let's go ahead and plot this image on the same graph. So C prime should be right here at the origin, C prime. A prime should be at -3, 3, way up here. And T prime should be at -4, -1. There we go. And hopefully you notice that the blue triangle and the red triangle are the exact same size and shape. They have preserved congruence. It's a rigid transformation. Last example, I might just give you ordered pairs and no graph, but you can still use that algebraic rule. Just see what's happening to the X coordinate, what's happening to the Y coordinate. We're going to assume this is a translation, since that's the only transformation we're learning about in this lesson. So whatever we're adding to the X coordinate and the Y coordinate should be the same to get C to C prime, O to O prime, L to L prime, and D to D prime, right? I'm just going to look at one of these points, and you can verify with the rest of them. I'm going to pick out point O because I like working with zeros. They're nice. What do I have to do to the x-coordinate of 0 to get an x-coordinate of -2, well, I have to subtract 2. So if I was to write my rule, which is what it's asking us to do, I'm going to say x is going to go to x minus 2. And then for y, what do I have to do to this 0 to keep it 0? I do nothing to it, right? It just stays a y. So it sure seems like this is my algebraic rule. I'll leave it up to you to double check that this rule holds to get c to c prime, l to l prime, and d to d prime. But it should hold, it does. As always, ask a question at the end of the video if something didn't make sense, or make up your own practice problem, and then I will see you all in class.